Hi, good evening. In this lesson, we are going to look at properties of exponents. This is lesson 2.1. There is another part to lesson 2.1, which is rational exponents. We will deal with that later. Let's take a look at what are the properties of exponents are. So we know the basic concept of an exponent. Say I have 2 to the power of 3. The number 3 is called the exponent and the number 2 is called the base. So 2 to the power of 3 is nothing but the base multiplied by itself 3 times. So that is 2 times 2 times 2, which will give me 8 as my answer. So this is writing in exponent form and this is my standard form number. So that's the basic concept of my exponent. So the properties of exponent basically involves applying this basic concept of exponent to make our problems simpler. So first property that we're going to look at is the product of powers property, meaning I have powers that has the same base. So that means, say I have a power 2 to the power of 3 and I'm multiplying it by another power which is 2 to the power of 4. As you can see, the bases are one and the same, but the powers may be the same, it may be different, it doesn't matter, but the base has to be the same. So if I have the bases as same, I can simply go ahead and add the powers. It will give me my simplest answer. So that's 2 to the power of 7. I can go ahead and figure out what 2 to the power of 7 is. That is 2 times 2 times 2, base multiplied by itself 7 times. So that's 2 times 4, 5, 6, 7. So I went in a roundabout route, right? So how exactly I got that 2 to the power of 7? If I took a closer look, 2 to the power of 3 is nothing but 2 times 2 times 2. I have a multiplication sign. 2 to the power of 4 is 2 times 2 times 2 times 2. So that's how I got 2 to the power of 7. So if I have powers that has the same base and I'm multiplying them, all I can do is just go ahead and simply add the two powers and I'll get my answer. So if I have to generalize this rule, I have a base a raised to the power of m multiplied by the same base now raised to the power of n. All I can do is just go ahead and simply add the two powers and I get the simplest form of my exponent. Alright, that's my first property, which is the product of powers. Now comes the quotient of powers. Quotient means I'm dividing two powers that has the same base. So the thing that is critical is I have to have the same base. Otherwise I cannot apply this property. So if I have a power, say 2 to the power of 7, and I divide it by another power that has the same base. So the bases are same. The powers may be same, it may be different, doesn't matter. All I can do is go ahead and simply subtract the powers, which will give me 2 to the power of 2, which is 2 times 2. So how did that happen? Say 2 to the power of 7, the basic concept of exponent is 2 multiplied by itself 7 times. Divided by, I have 2 to the power of 5, which is 2 multiplied by itself 5 times. Since all these people are being divided by all these people, I can go ahead and cross cancel these many 2's. They cross cancel each other. All I'm left with is 2 times 2, which is what I got. So the basic property, the quotient of powers property, if I have to generalize it, I have two powers with the same base. All I can do is keep the base, take the powers, and I can subtract them. So that's my general rule for quotient of powers property. The next rule that we are going to look at is the power of a product property. Earlier we saw product of powers, now it is power of a product, meaning I have a product. Say I have 2 times a. I have a product, let's say 2x. I have 2x and I'm raising it to the power of 3, right? So 2x to the power of 3 means I have this, if I take this as the base, that's my exponent. If I apply the basic rule of my exponent, it is the base multiplied by itself 3 times. Now the base is 2 times x. So it is 2 times x multiplied by itself 3 times. 2 times x. So if they are all being multiplied, so whether I have the parentheses or not doesn't matter. So if I just go ahead and remove all the parentheses, it is 2 times x times 2 times x times 2 times x. So if I put all the numbers that are alike, so this is 2 to the power of 1, x to the power of 1, 2 to the power of 1, x to the power of 1. So these are all powers that are being multiplied, right? So if all the powers that has the same base, I can put them all together. Because multiplication is commutative, I can multiply them in any order I want. So now this becomes product of powers. I started with power of a product. Now it's product of powers. So 2 times 2 times 2 is nothing but 2 to the power of 3. Similarly, x times x times x is x to the power of 3. So I started with 2 times x to the whole power of 3. I ended up with 2 to the power of 3 times x to the power of 3. So in general, what has happened is I took the power and I gave it to both of the factors that are in my product. So if I have two factors, a times b, that are being multiplied and I'm raising it to a power of m, all I can do is take the power and give it to all the factors in my product. So that's power of a product. Okay. The next comes power of a quotient property. So power of a quotient means I have two things that are being divided now. So let's say I have x divided by y. I'm raising it to a power of 3. Alright. So if I apply the basic property of my exponent, the exponent rule, which is the base multiplied by itself as how many ever the power is. So the power is 3 here, the exponent is 3 here, and the base is x over y. So I have x over y multiplied by itself 3 times. X over y multiplied by itself 3 times. So fraction multiplication is numerator times numerator divided by the denominator times denominator. So I can just go ahead and multiply all the x's together in the numerator, and I can multiply all the y's together in the denominator. So the power actually is a 1. If I don't see the power is 1. So I'm multiplying powers that has the same base. So x times x times x, as we know, it is x to the power of 3. Y times y times y is y to the power of 3. So what has happened is I have a quotient and I'm raising it to a power. I ended up with giving the power to both my numerator and the denominator. So if I have to generalize this, if I have a quotient a over b and I'm raising it to a power of m, all I have to do is I'm going to give the power to both my numerator and the denominator separately, and I can figure out what my answer is. That's my power of a quotient property. Next comes the power of a power property. Power of a power is I have a power and I'm raising it to another power. Alright, this is my outermost power and this is my inner power, right? So I have this 2 to the power of 3 raised to the power of 4. So if I consider that as my actual exponent, and this thing becomes my base, the 2 to the power of 3 becomes my base. So if I apply the basic rule of my exponent, it is the base multiplied by itself how many ever times the power is. So the base is 2 to the power of 3 and it is being multiplied by itself 4 times. So I can say it is 2 to the power of 3 times 2 to the power of 3 times 2 to the power of 3 times 2 to the power of 3. So here I am multiplying different powers that has the same base, so that becomes product of powers. So this is 2 to the power of 3, so I will have 3 2's here, another 3 2's here, another 3 2's here, another 3 2's here. That means I have a total of 12 2's, right? So that is 2 to the power of 12. So if I look at it closely, I can skip this whole thing. What I did here, I can skip this whole thing if I understand what is happening between these two numbers. So how can I get a 12 from that 3 and 4? All I have to do is multiply them. So if I have a power raised to another power, all I have to do is take the powers and I multiply them. Keep the base every single time. Alright, so that's power of a power property. So I have two powers. Yeah, I go ahead and multiply the powers. Alright, the next property that we are going to look at is a zero exponent property. This is the simplest one. So anything raised to the power of 0, 2 raised to the power of 0 is 1. I'll explain this whole thing, how it happened in class. Alright, so for now, let's just keep it. Anything raised to the power of 0 is a 1. So 5 raised to the power of 0 is also 1. Negative 5 raised to the power of 0 is also 1. A million raised to the power of 0 is 1. Alright, how did this happen? We will discuss this in class. So in general, if I have to write it, a 0 power, a to the power of 0 is 1. So that's my zero exponent property. The last property we are going to look at is the negative exponent property. Negative exponent is, say I have 2 to the power of negative 3. Some of you might think 2 to the power of negative 3 is negative 2 times negative 2 times negative 2. As you can see, my base is not negative 2. My base is 2. I cannot multiply 2 negative 3 times. It's not possible. So as long as I keep the negative exponent, I cannot figure out what that value is. So negative 2 times negative 2 times negative 2 is not 2 to the power of negative 3. It is negative 2 to the power of 3. So these two guys are not one and the same. They're not the same. So how am I going to take care of the negative exponent? So to take care of my negative exponent, I'm going to make it to a fraction. If it is not a fraction, I'm going to put it over 1. And I'm going to flip my base. My base is 2 over 1, right? So I'm going to flip it, make it 1 over 2, and the power automatically becomes a positive power. How this happens, we'll discuss it in class. So just for the sake of it, say if I have 2 to the power of negative 5. So how do I change it to a positive power? Make it to a fraction. If it's not a fraction, put it over 1, and I'm going to flip the base. So this becomes 1 over 2 to the power of 5. What if I have a negative power in the denominator? Say I have 1 over 2 to the power of negative 7. How do I make it to a positive power? Now I already have a fraction. All I have to do is flip the base and make it to a 2 to the power of positive 7. Okay, so what if I already have a fraction? Say I have 3 over 5 to the power of negative 2. As we said, this is a power of a quotient, right? So power of a quotient, I have to give the power to everybody. So this becomes 3 to the power of negative 2 over 5 to the power of negative 2. Alright, so as you can see, this 5 also has a negative power, the 3 also has a negative power. So that means I have to flip the whole thing. So if I flip the whole thing, I have to bring the 5 to the power of negative 2 to the numerator. When it comes to the numerator, automatically it becomes a positive power. And the 3, when it goes to the denominator, it becomes a positive power. So that 5 square over 3 square. So in general, if I have a negative power, a to the power of negative m, all I do is make it to a fraction and I flip the base and it becomes a positive power. Alright, if I have a negative power in the denominator, all I take is I take the power and flip the base and bring it to the numerator and it becomes a positive power. So that's a negative exponent property. So please go over all these properties, and we can use these properties to simplify exponential expressions, and also we can use these properties in our rational exponents. That's what we're going to see in the part 2 video of lesson 2.1.